workloads running on top of Hyper-V. And in this one, we're going to focus specifically on SharePoint. And I wanted to make sure that we had a good understanding of what we can do from a Hyper-V perspective, how we can tune it, how we can optimally configure it for many different workloads, and then we'll look at SharePoint specifically. Because one thing to be aware of is that when you're sizing and planning for a SharePoint deployment, you really need to still start with the physical elements of planning, so sizing for users, sizing for capacity, and then map that onto a virtual platform. And that's what we'll do through some of the scenarios we've got later on. So we'll take a look at why Microsoft Virtualization for server apps, so SQL, Exchange, SharePoint, just a bit of general information there. Then we'll look at some of the performance stuff across both Hyper-V in general and the workload specific. And then we'll go through some best practices. There is another good session on later today that will go more and more into SharePoint specifically. So if you're looking at best practices around deploying it in general, there is another good SharePoint session later today. But we're going to focus on some virtualization versions of SharePoint. So why would you want to put it on? Why would you want to put SharePoint and other key workloads on Hyper-V? And what does the Microsoft Virtualization Platform actually look like? Well, so many people compare VMware and vSphere and the whole of the VMware plethora of technologies with just Hyper-V. And Hyper-V is just our engine. It's just where the virtual machines run. It's performant, it's efficient, it's optimized for things like Windows and some of our workloads, but it's just the engine. When you're thinking about a more complete solution, really System Center makes it that complete solution, and is more of an apples for apples comparison if you're weighing up your next virtualization move. But we've got our platform, and we've got our key workloads on top, and this particular session is one of three. There was an Exchange one yesterday, there'll be a SQL one this afternoon, and SharePoint is obviously this one. And then stuff that plugs in, your line of business apps, your enterprise apps. We've published reports showcasing SAP on SQL very recently. Great performance, running on Hyper-V. But then where I'm really passionate about and helping people get value from the workloads they've invested in is System Center. Because System Center is a set of tools, a suite of tools, both from an integration perspective and a single license perspective, that really provides value at each of these levels. Whether it's your line of business apps that you want to monitor and protect, whether it's your core Microsoft apps that you want to monitor, patch, backup, and so on, whether it's Hyper-V, or even whether it's the hardware. So a lot of our hardware partners, from storage through to networking through to servers, are plugging into System Center now. And if you go down to the show floor, in the exhibition hall, you'll see this more and more. Just yesterday, I was walking past the EMC booth, which is pretty prominent right at the front. And EMC have started to produce management packs for System Center that allow us to monitor EMC storage and technologies side by side with our Exchange and our SQL and our SharePoint and so on. So it's rolling up all of that knowledge into one view, which is really, really useful and makes your life a lot easier. It's not trying to replace your life in terms of as the IT administrator or the business unit owner of a certain department. It's trying to help you, enable you with more technology to do more with less. And that is Microsoft Virtualization. So if you're weighing up, do I go with a VMware solution for my next platform? Do I go with a Microsoft solution? Make sure pay due diligence to the Hyper-V and System Center technologies, because they're really very, very well integrated and suited together. And just building on that, if you do start to deploy these key workloads like SQL, Exchange, and SharePoint on Hyper-V, what you'll find is you've got a single support statement right through the stack, from workload through to guest OS, through to hypervisor and Windows that surrounds that. There is a partner ecosystem that's really starting to build. I gave the example of EMC a minute ago, but just at the start of the week, Veeam announced support with their excellent backup technologies that now plug into Hyper-V. So if you want to start to use their technologies, maybe you've got an investment in that from a VMware perspective and you want to embrace it with Hyper-V, you can feel safe in the knowledge that they will plug in really, really nicely. And again, an example of this growing partner ecosystem, both from a vendor perspective and a system integrator perspective. I know we'll have a lot of partners who work in various countries across the world here at TechEd, not just end clients, and they're interested in System Center and helping you get more from your technology platforms. But System Center, as I said, is where you glean that deep application knowledge. So using something like Operations Manager to monitor SharePoint or SQL or Exchange, And the beauty of this is it's not the operations manager team who are writing these management packs, these packs of knowledge about, they're not finger in the air and thinking, should I monitor that in Exchange or should I monitor that in SQL? The teams that are producing the products, so the SQL team, the SharePoint team, and so on, they are producing the packs, and they're all free. So if you've made an investment in Operations Manager and you want to start to use it to monitor these key workloads, you can download the management packs for free. And they're evolving and they're improving all the time. But one of the things that's very unique to a System Center is that management across physical and virtual. How many people are what they would class as 100% virtualized today? Yeah, one person, okay. Now, obviously, you've got the physical host, so there is still some element of physical infrastructure. That would just be magic. But a lot of organizations still have some workloads that aren't virtualized for whatever reason. Some people still feel cautious about virtualizing things like Exchange and SQL and SharePoint and Oracle and so on and so forth. And for that reason, management tools that ship with platforms like VMware don't offer that integrated story to help you manage those workloads. And that's, again, where System Center really plays a big part, but also extends to the desktop. So System Center Configuration Manager is a widely known and well-regarded tool to help you manage and configure and deploy desktops. It can do the same for servers as well and manage your patching across the whole infrastructure, but it's certainly a very, very efficient desktop tool, from a physical perspective. But also VMM, Virtual Machine Manager, again, part of this System Center suite, not only manages Hyper-V, but it manages VMware as well from the same console. And in Virtual Machine Manager 2012, launching at the end of this calendar year, what you'll find is it not only supports Hyper-V natively, VMware through vCenter, it also supports Citrix Zen Server. So if you've got an investment in that, maybe you've virtualized Zen app, or maybe you've virtualized using Zen Desktop with Zen Server, we can bring that in and start to manage that side by side. And Citrix are also developing for their latest version of Zen Server, codename Boston, version 6, they're releasing more and more efficient management packs to allow us to monitor that as well. So again, that ecosystem and that cross-heterogeneous environment is really, really key. But then we come to cost. And it wouldn't be very good if I was talking about all of these technologies and then saying, you know what, they're all great, but they're going to cost you millions and millions and millions of dollars to acquire them. It's not the case. System Center and Hyper-V, very, very cost-effective. Hyper-V is actually free as part of Windows Server. It's also free as a standalone download if you want to go that way. And System Center, as its suite of tools, is a single license to acquire all of the System Center technologies, from Operations Manager to VMM to Configuration Manager and so on. And we'll touch on that a bit later on. But that's our story, and the reason why this platform is the best for these server applications is it helps you get the most out of them. The last thing you would want to do is buy a really shiny Ferrari and only drive it at 10 miles an hour. You want to ensure you can get the best out of these workloads, and that's where System Center, through its monitoring and protection, can really help. But what's in Hyper-V? Many, many people still haven't had a look at Hyper-V. Just out of interest, how many people are running Hyper-V? Brilliant. So I'm guessing you guys have had a look at Hyper-V. But there's still a few. How many people are running VMware? I think we asked this before. Yeah, okay, fair few. Some hands the same, actually, which is interesting. But Hyper-V has evolved release on release. And from a maturity perspective, we're now into this third release. So 2008, 2008 R2, and then Service Pack 1. And within 2008 R2, we introduced live migration and high availability. And in terms of if you've not seen that on the Hyper-V platform, if I quickly flick over to my box here, and I bring up Failover Cluster Manager, which is just our management interface to manage failover clusters. The name kind of give it away there. I didn't really need to explain that. But if I want to start moving workloads around, I can right-click, I can choose Live Migrate to another node, Live Migrate, and that's going to go away and it's going to move that virtual machine across to another node in that cluster. And that's free. Okay, there's no cost associated with that. It's built into the Windows Server Hyper-V licensing. It's built into the free Hyper-V server you can download. So a very, very cost-effective way of acquiring the technologies that no doubt if you're running VMware, you've become accustomed to, but at a price. So that's a little bit, just a very, very quick glimpse at live migration. Now in my environment, I've got a 2-node cluster. It's catchily named Hypercluster 1, and it's got Hypernode 1 and Hypernode 2. I know, I I don't get out much in terms of my naming conventions. If you do want to borrow those names, that's absolutely fine. But in my environment, if I was to lose one of my nodes, say Hypernode 1, because the clustering is there and it's built in, all those VMs would fail over to Hypernode 2. So I've got that resiliency in there. And that will become important when we talk about SharePoint later on and providing an extra tiered level of resiliency. You can have up to 16 nodes in these clusters. I don't know why I'm doing this. I mean, symbolizing that 16 nodes would fit in this space. You could have 16 blades. You could have 16 racks, 16 towers. It doesn't matter. But 16 nodes and scale up to 1,000 virtual machines on there. Now, that is a big, big infrastructure. That's a lot of VMs per host, but it's feasible, and people are doing it. And we've got benchmarks that show it can be done very, 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 very easily. So let me just flick back to my slides. So we've looked at live migration. I'm not going to take down my host because it's in Edinburgh, and I would really struggle to switch it back on because I don't have any lights out. So I'd have to get somebody up in the middle of the night, or, well, middle of the day to go and sort that out. But in terms of other things and performance, if anyone's bought servers in the last 2 or 3 or even 4 years, they're going to be high performance. A lot of cores, high levels of performance there. Hyper-V will take advantage of that. Really, really improved in 2008 R2. We'll see some of the density you can achieve now. And when we look at networking a bit later on, specific to SharePoint, I'll tell you how, from a best practice perspective, you should be thinking about configuring your Hyper-V hosts. Because there's a lot of confusion out there about networking. And do I use 4 cards in the host? Do I need 8 cards? Do I need 12 ports? And so on and so forth. How do I divide them up optimally? And I'll touch on that as well, because that's important no matter whether you're deploying SharePoint on Hyper-V, file servers on Hyper-V, it doesn't matter. Putting this solid foundation in is going to set you up a lot better for going forward. But then finally, at the bottom there, in fact, just before we get to the bottom, has anybody deployed Windows Server in server core mode? Okay, less hands. Server core, if you're not familiar, is a GUI-less install of Hyper-V. I say GUI-less, I mean, it's got a shell, it's got a command prompt there, you can interact with it. But it's a smaller subset of the capabilities, it's a smaller footprint on the disk, it's typically a little bit quicker to install, but you need to really be managing it remotely. But that's a deployment option that some people choose to have a more locked down Windows Server. You can enable the Hyper-V role in that and a number of other roles, but you couldn't really put SharePoint on there, particularly the back end of things like SQL and the application server. So, bottom point there, dynamic memory and remote effects. They were introduced in Service Pack 1. And what dynamic memory gives us, because I'd rather show you it than go through it in slides. Let me bring up Hyper-V Manager. So as the name suggests, this is the MMC interface that helps me to manage Hyper-V. These aren't System Center. These are just literally the MMCs that many of you will be familiar with. But what you can see on this particular node is a number of virtual machines are up and running, some busier than others, but some of them have got this assigned memory, memory demand, and memory status columns. Now, if we start with memory demand, this is the guest operating system, regardless of the workload it's running, saying, Hyper-V, I need this much memory to do my work at this point in time. So at this point in time, if we look at the app vServer, which is used to stream applications, so it's application virtualization, it's not doing a great deal. The CPU sat at 0%. The memory demand is just over 900 megabytes. So that's AppV and the Windows OS saying, this is what I need, to Hyper-V. And Hyper-V is saying, OK, I'll give you that, but I'll give you that little bit extra, hence why we're giving it a gigabyte exactly. But if we look at the settings of this particular virtual machine, and I look at the memory settings, it allows us as administrators to set a minimum and a maximum, and the Hyper-V will fluctuate and manage the amount of memory it gives to that virtual machine at any point in time. So you'll see that this VM will actually start with half a gig. It's grayed out because the VM is running. I can only change these figures when it's switched off. So between half a gig and 1 gig. And this will be really useful later on when we look at some of the SharePoint scenarios where you're trying to scale up your infrastructure, but SharePoint as a workload might be very, not seasonal, but it will peak and reduce in consumption based on time schedules of users accessing it. So having dynamic memory can reclaim some of the resource that you can use for other things. But you'll notice we've got this buffer, and it's set at default 20%. That's why, when we look at the app vServer a minute ago, it only needed 900 meg, but we gave it a gig. We're giving it that little bit extra just to account for any minor fluctuations. If there was contention for memory on the host, so if the host was completely exhausted of memory, that buffer would be the first thing to go. Okay? And it would start to take memory from the virtual machines based on priority. So if you've got a really, really important VM that you think, you know what, if there's contention, if I get into a situation where there is contention, and I need to ensure that this workload is prioritized over others, slide that up to the right, up towards high. If, however, it's a file server or something that's less important in the event of real contention, slide it to the left. Okay? And that will be one of the VMs that will have memory taken from it first. So something to be aware of. You can apply this to different workloads. Exchange, you probably wouldn't, because Exchange tends to utilize all the memory you give it to effectively improve performance, whereas other workloads like file servers, print, and so on, and web workloads will scale much more efficiently. So that's a little bit about dynamic memory. And you can see that this particular VM is low. That's kind of the middle tier in terms of warnings, because warning is a little bit worse. And you see this particular VM, at the moment, it needs 4.3 gig, and I've only given it a maximum of 3. So that's a sizing issue. I've incorrectly sized that virtual workload, but that's because I've not got a huge amount of RAM in the actual physical server. But it's allowing me to find that balance. But some servers, I've not even turned it on. Okay, I've chosen not to on my NetScaler VPX. And we'll actually talk about NetScaler a bit later on because it's very relevant to SharePoint. So that's a little bit about dynamic memory. It does buy you that flexibility, that efficiency, more efficient use of memory. And what it gives us from a performance perspective, some of the workloads we've seen from our partners like Citrix and Quest, upon release of Service Pack 1 for virtualizing virtual desktops, they saw gains in excess of 40% density. In one test, Quest saw that the density increased by 100%. So they went on a 72 gig of RAM host, they went from 60 VMs to 133. And they weren't just doing how many VMs can I start competitions. Oh, I can start another one, yes. They were doing workload generation tests using industry standard testing methodologies like Login VSI's workload generator or Login Consultant's VSI. So again, tools that are available to you to test in your environments. Hyper-V has come a long way. Many of you come to TechEd because you enjoy and you're passionate about technology, and I'm the same, and I cannot wait for what will come down the line. I don't know what's coming in vNext of Windows Server and Hyper-V, but if it continues on this evolutionary path from 2008 to R2 to SP1, we know it's going to be good, and it's going to come at a great price point, I'm sure. So now we get into some of these guidelines, and I think these are really, really important, and they're sometimes overlooked. And these are applicable. These aren't specific to SharePoint. These are applicable to any workload that you're going to run on Hyper-V. From a memory perspective, people just assume when they read on the web, you know what, I'll just give the parent, i.e. the Hyper-V OS that's sat on the physical hardware, I'll just give it a gig of RAM, it'll be fine, or I'll just give it half a gig. That's what I've kind of heard on the grapevine that's okay. But if you want to start being a little bit more accurate, it's best practice to allocate half a gig to the parent, okay, plus the per VM values. And this isn't unique to Hyper-V. This affects VMware in a slightly different way as well, but you struggle to find the information on the web, trust me. But in terms of, I'm being open and honest about this with Hyper-V. So how you start to work this out, and this is something you should be aware of when you're sizing things. So for each virtual machine, you allocate 32 meg for the first gigabyte of RAM you've given to a VM, okay? And then 8 meg per subsequent gigabyte. So the cost for that VM for a 16 gigabyte virtual machine would be 32 meg plus 15 times 8, which accounts for the remaining 15 gigabytes times by 8. So that means for that particular VM, the overhead on the host would be 152 megabytes. So not a huge amount. If we had 8 of these VMs, 8 16 gig VMs running on a single host, the overhead would be just over a gigabyte. So not huge. Some people just recommend saying, okay, just go with 2 gig for the host and you'll be fine. It will account for pretty much everything, which is a fair assumption. But if you want to be that little bit more accurate, that calculation would help you out. Some people don't bother. You know, they just go, you know what, I'm not worried about that. But I would say, just have a think about it. You know, be aware. It could catch you out. It's never caught me out, and you can set reserves and so on, but it's just something to be aware of. But then networking. Networking is the one thing that catches people out with Hyper-V. I've had so many questions about Hyper-V networking, how it works, how how the different types of networks work, and so on. But I've also had a lot of questions on just how many do I need? What is best practice? The questions often start with, if I do this with VMware, how would I do it with Hyper-V? From a networking perspective, I need one network for this. How does that map to Hyper-V? Now, I've pinched this little table from a guide that was produced actually by the Microsoft business unit within NetApp. And irrespective of the storage bits in that article, it's certainly a brilliant document, and I always have it on my laptop to send to people because it really helps you understand the networking. And it's probably the most concise guide you can find. And if you do a search using your favorite search engine, which I know will be Bing, do a search for TR-3702. TR-3702. That guide, pull down the latest version, and it's got lots and lots of useful information. I assure you, it's very, very good, irrespective of the storage you're using. Okay, if you're using NetApp, great. There'll be more information that's relevant, but from a networking perspective, it doesn't matter. But anyway, how would I start? How would I figure out how many NICs I need in my host? Well, let's divide up these networks. Firstly, one for management. This network is used by you to communicate and administer that host. Hyper-V has nothing to do with this NIC, nothing to do with it at all. It's just like a normal physical NIC that you would use to connect to a normal physical server. The reason we advise allocation of a management network is because if you rely on utilizing the VM network, sometimes the traffic from VMs can get so high and saturate that network that you may not be able to reach the box to manage it. Hence why we say have a dedicated network for management. When it comes to virtual machines, so dedicated NICs for virtual machines to use for their traffic. This is really important from a SharePoint perspective because users are going to be coming in and out and checking stuff in and so on. It says 1 or 2. That will vary depending on your workloads and your I/O. And we have tools and assessment tools that can help you get an idea of the levels of networking I/O that are being generated by your workloads that you're thinking about virtualizing. If you've not heard of the Microsoft Assessment and Planning Toolkit, version 5.5, that will do a capacity planning exercise on your estate and give you information such as disk I/O, networking, CPU for all of your workloads. So if you're thinking of consolidating down, that kind of information is really useful. If you're using fiber, then the iSCSI column wouldn't apply. But if you're using iSCSI storage, just out of interest, how many people are using iSCSI-based SAN storage? And everyone else fiber? Okay, interesting, okay. iSCSI is starting to really pick up and really gain more and more popularity. I think we're past that stage where, fiber's 1,000,001 times more performant. Let's go with iSCSI. People are happy now with the performance levels of iSCSI and the flexibility and cost model as well. But we recommend 2 NICs for iSCSI as a minimum. The reason being is you can carve them up and ensure that you've got multi-pathing, which we'll look at in a minute. When it comes to a cluster network, this is also known in legacy Windows terms as a heartbeat. Now, there are differing sources on the web that say, you know what, you probably don't need a heartbeat network anymore. The rest of the networks, if they're common across all of the nodes, you can use those to heartbeat. But best practice is still to separate out and include a heartbeat network. Then the final 2. Number 1 is migration. That really should say live migration. When I did that live migration of that virtual machine earlier on using Failover Cluster Manager, I was sending that traffic, that immense traffic, that data, across a single physical NIC or a single network, isolated from my other networks because we're saturating that link as much as possible. We don't want that to impact our users who are accessing SharePoint or you're trying to manage the box. We don't want to utilize those networks. We want dedicated live migration networks. And something that's important and often catches people out is how I actually specify this live migration network. Now, I unfortunately am not adhering to my own best practices here, so I've only got 4 NICs in this box. However, bear with me. Let's pretend we've got 8. And if I click on one of these, in fact, if I click on this particular server, click here, and I view, I think it's this one actually, view properties. See here, network for live migration. That's where you specify it. Okay, a lot of people don't know that. It's tucked away, it's hidden, it's there. Okay, so if you had your 8 NICs, your 8 separate networks, you'd have a longer list than me. That's where you'd tick it, okay? Do you want to turn on jumbo frames for that network and other network optimizations? Yeah, sure. That will improve performance. Certainly for your iSCSI NICs, you would certainly want to put on jumbo frames. But before you do that, make sure your switches and all the other bits and bobs of your infrastructure are configured for jumbo frames. Because if you don't, and you start to try and connect to your storage, you could encounter problems. Not that that happened to me or anything. You know, not that I didn't check the switches and with a simple ping test. Absolutely not the case. No, honestly it did. You only need to do that on one VM. So if you were setting up a fresh cluster, you'd build a test VM. It doesn't have to have anything in it. It doesn't have to be an OS-based VM. It can just literally be a blank virtual machine. Right-click it in the middle there, not over here on the left, not the config file, just this top one here. Right-click, Properties, Network for Live Migration, and you're done. You can't do that in System Center. You have to do it here in Cluster Manager. Okay? One of the little things to be aware of. And once you've done those, once you've configured those networking elements, you're good to go. You know, the final network is something called Cluster Shared Volumes, which is our storage-enhanced technology for 2008 R2, which allows you to put lots of VMs on individual LUNs of storage, but it also introduces some improvements in resiliency. And a lot of backup tools, particularly Data Protection Manager 2010, will utilize that CSV network, so it's important to have one if you can. But what I've shown there, iSCSI network aside, is individual NICs. And you're going to say, well, what about, there's no resiliency in those NICs. What about teaming? What do I do about that? Well, teaming is provided in this release of Windows and in previous by the NIC vendor. Now, initially, when 2008 R2 launched, there was a bit of confusion, a little bit of, some of the drivers weren't as good as we would like them to have been. Some of the teaming utilities weren't quite up there. Now we're in a much, much better place. If you're running HP servers, make sure you download the latest PSP. I think it's 10.22, I think was the latest one. If you're using Broadcom, you can grab those from the OEM vendor. If you're using Intel, again, grab them from the OEM vendor. Don't be tempted to go to the individual NIC vendor's website like Broadcom or Intel, because sometimes they haven't been validated by the OEM. Okay, so if you're putting them into Dell servers or HP or whatever, or IBM, get them direct from those vendors. Not that that's ever stung me before at all, honestly. So acquire those optimized drivers, get those utilities from the NIC vendor. That's a big piece of advice. But then we come to storage for the host. Now, if you're testing Hyper-V or you're testing a standalone set of hosts with no shared storage, that's fine. That's entirely fine. But if you do want to do failover clustering and the live migration I showed earlier on, you're going to need either iSCSI, Fiber, or FCOE storage. Okay, so you're going to need some kind of shared storage. How you connect to that and how you configure it, let's have a look on my machine. And let's go over to Hypernode 1. Now, I'm utilizing iSCSI storage, so I'm connecting with the iSCSI initiator. I'm hooked in, it picks it up on boot, and I'm connecting actually to 2 targets, so 2 controllers. And I've got 4 devices, so 4 LUNs that are being presented back to me. Okay, so 4 elements of storage of varying shapes and sizes. It's actually really, really easy now to hook Hyper-V onto shared storage. You can literally put the IP address or the name, DNS name of the iSCSI target in that box, click Quick Connect, and it will pretty much do everything else you need. Okay, so much more straightforward than perhaps previous versions of Windows with the iSCSI target. But once you've got the iSCSI target and that kind of bit's hooked up and you've got your drives, if you've got multipathing, if you've got multiple routes to this SAN storage like I have, you may see duplicates of the disks in Disk Manager. And that's because you haven't turned on MPIO, so the multipathing. All of these can be turned on within Server Manager as features. So I'll turn on MPIO. I've already turned it on, obviously. But my big piece of advice is, if you're just testing, if you're doing a POC and so on, you can use the inbox device-specific module, which means the framework for load balancing and resiliency for these multiple paths to your SAN. However, if you're putting in production, I would recommend getting hold of your storage vendor's DSM, device-specific module. Okay? Because what that means is that they have optimized that for a certain type of load balancing traffic, a certain configuration. Maybe it's round robin, maybe it's a number of the other different alternatives, but either way, they will have tuned that for their storage. Okay, so very, very important. And they will usually make those tools available for free. Now, the beauty of Hyper-V is we don't penalize you for wanting to use third-party DSMs. That's not the case for all hypervisor platforms. Okay? There's no skew that you have to embrace with Hyper-V to take advantage of these optimized DSMs. And it's very, very straightforward to import those. Usually, in the example of NetApp, double-click the installation, and it will configure it all for you. You don't have to import anything manually and so on. It's very, very straightforward, just like installing a normal application. So for iSCSI, certainly a gigabit infrastructure is recommended, and I'm sure that's what many... Does anybody have 10 gig? 10 gig Ethernet? 2 or 3? Wow, OK. 10 gig, I think if we ask that question next year in Orlando, hopefully see you there if you're going to be there, or in Europe, I'm sure 10 gig, there'll be a few more hands, and it will creep up and creep up and creep up, because people are starting to think, you know what, the levels of data, the amount of I/O, the performance I'm looking for, 10 gig is going to really give me that future-proof platform. As I said, turn on things like jumbo frames, specifically for your storage. Very, very important, because that will increase performance. Bigger payloads per packet, more efficient performance. But don't just turn it on for every network, because not every network needs jumbo frames. We've talked about the iSCSI initiator and MPIO. Utilize that storage vendor's DSM. Very, very straightforward. So now we get on to the guest. And this is, again, applicable no matter which workload you're going to run on, whether it's SharePoint, whether it's Exchange, SQL, file server, or whatever. Ensure the integration components are present. Now, these are little tools that exist inside the guest operating system, or you install them in there, to improve the performance of things like storage, networking, I/O, and whatnot. If you're putting Windows Server 2008 R2 on top of Windows Server 2008 R2 Hyper-V, you don't need to worry about these. They're already there. Same if you're putting Windows 7 on R2 virtualized. They're already there. Older operating systems, though, you'll want to manually update them. Okay? Now, there are, again, we come back to that networking. It often confuses people. Let me just briefly go back to my demo box and go to Hyper-V Manager. And I'll choose a VM that's off so I can modify it. So we'll look at the settings. You see here, this particular virtual machine. We've got here, there we go. That could have been nasty. So this particular virtual machine here, we've got the option to add network adapters and legacy network adapters. If you can, always use network adapters. Legacy should only really be used for PXE booting, because the performance difference is quite significant. Okay? So you would need to use the legacy one for PXE booting, because there's no driver for the network the synthetic network adapter until it gets into Windows. Okay? So pre-boot environments use the legacy one. But you can mix and match. So you can have 8 synthetic and 4 legacy attached to a single VM. Particularly useful for network load balancers or virtual firewalls or SharePoint, where you want to enable a number of different routes into a particular virtual machine. So you can very easily add those and assign a static MAC address, a dynamic from a pool, or even give it a VLAN address if you want. So I'm going to come out of there. So certainly I recommend utilizing the synthetic ones if possible. And don't forget, those optimized NIC features like jumbo frames, TCP offload, large send offload, and so on that can really enhance performance in the physical world, they're in Hyper-V NICs as well. So if you were connecting a VM directly to your iSCSI SAN, using that iSCSI initiator, the same one we showed before, straight from the VM to the SAN this time, you can utilize the jumbo frames and so on that we talked about. So again, don't feel that it's a disadvantage from a networking perspective to utilize the virtual NICs. When it comes to storage, again, I'm going to quickly flick back to my demo. When it comes to storage, let's have a look at this one here. Oh, they're grayed out because it's saved. Let me choose one that's off. Here we go. By default, a machine will ship with a virtual IDE controller. You can add virtual SCSI controllers as well. The performance difference is negligible. But for booting, your VHD, your virtual hard disk, needs to be attached to IDE. It has to be, okay? Because the drivers for SCSI aren't loaded until it gets into Windows. which would be impossible if your boot drive was attached to the SCSI. That's point number one. Some people like to separate page file from OS drive and store it on another disk. If you're going to do that, that secondary VHD will also have to be attached to an IDE controller. Okay, because when Windows creates the page file on boot, it's going to do it before the SCSI controller driver is loaded. Okay, so again, the IDE controller. And there are you'll see there are two here, IDE controller 1 and 0, and we can add another hard drive to that or another DVD drive if you want. So just something to be aware of. But the nice thing about the SCSI adapter, let's check the SCSI adapter here. If I want to add one here like this, no, I don't want to continue there. I can hot add hard drives while they're running. Okay, that's a unique feature of the SCSI controller. So if you've got a VM that's already up and running and you think, I want to add another drive for logs or for such and such, you can do that while it's running. And I can actually add up to 4 SCSI controllers, and each one of those can hang about 64 or 60, around 64 virtual disks off a single SCSI controller. So you've got about 250 disks per VM and 12 NICs. So you can create some quite strange virtual machines. So let me quickly go back to that. But these are best practices regardless. Now, you would size your VHDs for the contents. If you're just putting the OS in there and you're separating the SharePoint binaries and the logs and the SQL bits, then yeah, you can separate out your VHDs and reduce the size. But I would recommend, for workloads like SharePoint, SQL, Exchange, fixed VHDs. Now, a fixed VHD is like a buy now, pay now approach. And what I mean by that is, you say, I want to create a fixed VHD for my SQL VM. I want it to be 40 gigabytes in size. I'll lose 40 gigabytes on my storage. Gone. Dynamic VHDs, on the other hand, I want to create a 40 gig dynamic VHD. It's going to start from 0 megabytes, and when I install the OS, it'll grow to 10 gig. When I add SharePoint, it'll grow to 15 or whatever, and it will stay at 15, and as more stuff is added, that VHD will grow. The performance of dynamic VHDs is slightly less than that of fixed, but you do get that utilization of storage in a slightly different way. So there's a trade-off there. But for SharePoint, SQL, Exchange, and high-end workloads, certainly go for fixed. We've looked at dynamic memory already, so I'm not going to go into that in any more detail. Hopefully that's... but there is, in fact, one important point right at the bottom there. The guest and Hyper-V work together, but the guest OS has to support dynamic memory for us to work with it. So not every guest works with dynamic memory. XP is one example. XP will not work with dynamic memory. It does not support the way we hot add and balloon up that memory to get it back out. So the guest OSs that do support that, Windows Server 2003, Web Standard, Enterprise Data Center, 2008, 2008 R2. And from the client side, it's Vista, Enterprise and Ultimate, and Windows 7, Enterprise and Ultimate. Okay? They're the ones that will support it. Now, when it comes to Linux, because we're supporting more and more Linux distributions on Hyper-V, at this time, dynamic memory isn't supported with the Linux distributions because it doesn't have that memory VSC driver in there yet. But you can guarantee that if there's more and more demand for it and the evolution that we're going on, I'm sure that's something we will see in the future, but I don't know for sure. But I'm hoping it will. So, a bit about performance before we get into the SharePoint-specific stuff. A lot of perception about Hyper-V and performance and a lot of stuff that's out there, which is, a lot of it is mythical, it's poor perception. Performance-wise, Hyper-V is very, very performant indeed. And some of the guys that have performed this virtual reality check, which is in phase 3 now of the test, they're here this week. I think they had an interactive session yesterday. What we've seen when virtualizing memory-intensive workloads like terminal server is that with Hyper-V taking advantage of hyper-threading that exists in the hardware, in the CPUs, we actually outperform by 15%. That's not a bashing of VMware. That's a validation that both Hyper-V, VMware, and Zen Server are all performant platforms for virtualizing key workloads. And don't be afraid. When scaling up to 100 TS sessions, so you could in some ways equate those to users accessing SharePoint, busy stuff going on from a memory perspective, the response time on vSphere increased with every session beyond 100. But Hyper-V was very, very performant beyond that. And very, very close to bare metal. again, which is an important consideration. But in 2010, we commissioned ESG, Enterprise Strategy Group, to release a white paper sponsored by Microsoft on the kind of things we've covered already today. Hyper-V is easy to install. It's a tick box, next, finish. We've gone through a bit more of the detail today around tweaking the NICs and how you would carve your storage and connect to it and so on. But it provides HA and live migration out of the box. Very, very cost-effective way of acquiring it. And the performance is very, very close to physical. Again, very, very important. I mentioned that cluster before, 16 nodes, this big. You can get 1,000 VMs on there. That's a lot of virtual machines. Okay, and that was using EMC storage at the back end. But actually, Microsoft recently released our support statement that we will support 1,000 VMs on less than 16 nodes in a cluster. In fact, we support 384 VMs per node. Now, just because you can, doesn't mean you should. I don't think anybody in the room will be anywhere near that, and I've never seen anybody anywhere near that. But still, you can be supported running those kind of scaled workloads. So realistically, you could run a 3 or 4 node cluster and hit the big 1,000. But again, you'd scale it out because they would need to be massive servers, ginormous. And in terms of the disk performance, very, very close to physical for both SQL, for both transactional stuff, file serving, and Exchange. So be safe in the knowledge about virtualizing these workloads. And final bits on performance. We recently tested when Intel launched the new 5500, so the new Nehalem. Seems like ages ago now. If you speak to Intel now, they're talking about new and exciting technology way beyond the 5500. But with that combination of 5500 processors and 10 gig Ethernet and the combination of advanced networking technologies that offload stuff to the CPUs and vice versa, what we found was we could push 1 million IOPS across a single link through the software iSCSI initiator that I brought up before onto a Hyper-V host or a native Windows server. And we pushed 700,000 through a Hyper-V guest. 700,000 is a huge number, and very few people will ever need that level of IOPS. But it's good from a performance perspective. And again, the performance, if you look at that right-hand graph, when it gets to the more common 4K and 8K blocks along the bottom, the performance of both Hyper-V and that other line, which is native, they're equal. So we're on par. So when we get to the performance, very, very quickly. This was the test lab. This is now getting specific to SharePoint. Okay. Oh, yep, sorry. Good question. So I think they were done. So the question was, to repeat, were they done with GUI? Were they done with Core Edition of Windows Server? Or were they done with Hyper-V Server, which is the free download? I believe they were done with the GUI version. But the performance wouldn't be very different at all across all three. Obviously, the first one, where it was purely physical, that wouldn't be done with Hyper-V Server. I think that would have to be done with GUI. So I presume both were. But yeah, good question. But this is the test lab that ESG used in 2011 to validate the workload. So this is where we're going to get SharePoint specific now. So first up, look at their physical server. I have server envy. So they've got BL680s, big blades, 24 cores per blade, and 128 gig of RAM per blade. So we've had a running kind of competition in some of the other sessions. Can anyone trump that in server size? Has anybody got more RAM than 128 gig per? Yeah, somebody put their hand up. Somebody, yeah. 256? 384? How many have you got? Half a terabyte. Again, every time I do this, I cry a little bit inside because my servers have 24 gig of RAM. I do. I have major server envy. In fact, I would like your autograph at the end. I'm just kidding. So, I mean, that's the state of things today, though. You can scale up these servers ginormous. You know, they're huge. But more and more of these platforms, because the DIMM sizes, the 8 gig DIMMs, the 16 gig DIMMs, are starting to drop in price, these big size servers are more and more affordable for organizations. But that's what they tested on. They had a load balancer in front that was specific to, obviously, this web-based workload that is SharePoint, with users accessing and so on. They were using fiber channel storage, and they were using a pretty big array at the back end. So 155 disks, not solid state, not SATA. They were using SAS disks, 15K, fiber channel disks, and they were splitting these across a number of different RAID pools. some for the guest OSs. So you'll see there 24 pools for the guest OSs, for the VMs, 16 for the apps. The logs were separated in the data. That is a good best practice to do that, regardless of size. Separate those LUNs out to run the different backends of your virtual machines. But that's the physical test bed for which they tested SQL, SharePoint, and Exchange. But let's look at the SharePoint-specific test. Oh, wrong one. So they used a load generator built into Visual Studio, which I believe was on a physical server. They used that one of those big blades, 128 gig, with the relevant 24 cores, which is achievable now relatively easily. AMD have got 12 cores out, Intel are on 8 cores, so you can very easily scale to those kind of numbers of cores. But look at the SharePoint configuration. So they tested a SQL backend, a single server with 32 gig of RAM, 4 virtual processors, which is Hyper-V's limit today in terms of virtual processors. We can go to 64 gig of RAM, but it's 4 vCPUs. But they tested 4 and 32 gig of RAM for the SQL database. But for the website servers and the SharePoint application server, they were pretty regular. 2 virtual processors and 4 gig of RAM. Some of my VMs have got 4 gig of RAM. You know, I'm up there. I'm there with the testing. But I haven't got, obviously, I couldn't run the 32 gig one. But all they've done for these tests is they've tested first a SQL, SharePoint, and 1 web server, and then they've scaled it up to 2 and 3 and figured out where the performance benefits really come as part of that. You'll see the virtual machine images are on fixed VHDs at the bottom, and they're all separated. The SQL data and logs for the database tier, they are on separate VHDs as well. And they'll be using the SCSI connector that I showed you earlier inside the virtual machine. So what did they do? And this is the one test they ran for a lightweight workload. Now, I don't know about you, and is anybody running SharePoint through whatever flavor in their environment? 2003, yeah, okay, quite a few. You'll have users like me who would be a lightweight user. I don't know about the non-blocking bit. You know, no, you can't use it. I'm just a very lightweight user of SharePoint. You know, I browse stuff, I pull down a document now and again that I find. Maybe I'll upload some stuff, and I'll check some stuff in and out if I'm being particularly adhering to good behavior, which I'm sure everyone will in the room. Checking stuff in and out is good for versioning. From a content database, you know, that's not a bad size. It's not ginormous, depending on the size of the organization, but it's a good size. But that kind of workload, I think, is pretty reflective of how I would use SharePoint. And to be honest, a lot of users are probably the same. You'll get some other users who are using things like Excel services and some of the more advanced forms-based stuff and performance point and so on and so forth. So they probably wouldn't fit into a lightweight workload. But I think you'll find a lot of users would probably fit into this, more or less, within close proximity. So that was the workload generator. Remember, they're using Visual Studio 2010 for SharePoint to test this, so it's something that's accessible to you that can be really used to help you plan. And this is irrespective of Hyper-V. You know, so if you're planning a rollout of SharePoint, these load generation tools and the best practice stuff that's on TechNet can really help. So they scaled it from 1 web server to 3. They kept with just 1 SQL and 1 SharePoint application server, and they had a hardware load balancer for the web traffic. Now, in this case, it was F5. We'll talk a bit about NetScaler from Citrix later on, but it could be, I mean, you could even potentially use NLB. But in this production environment that they're trying to replicate or simulate, they used F5's big IP, who are on our stand downstairs. So let's have a look at what happened. So in this first test, best practice for them was to split the tiers of SharePoint, and I'm sure many of you would do the same. Have your data tier separate from your web tier, separate from your application tier. Yes, you can combine them. You could run it on a single server, but best practice in production, you'd probably want to separate them out. Now, as you can see, with 1 web server, so that was getting all of the traffic from those users, they hit a CPU bottleneck. So remember that web server's got 2 virtual processors? They hit a bottleneck. How could they have got over that? Well, they could have added extra vCPUs to that VM. That's one way. Certainly adding them any more RAM I don't think would have made any difference. Look at the SharePoint usage, the application portal, or the application server more specifically. Doing very little, pretty lightweight. The SQL server's ticking over at about 38% utilization, so not a bad rate. Room for scale, a bit more headroom. But the web server's the worrying bit. It's bottleneck there, okay, based on that workload generator. So what did they do? Well, they added another web server. In fact, they added 2. And you'll see now, by adding these total of 3 web servers, that the traffic and the CPU utilization dropped to around 70%, which is good. You want to get utilization out of these servers. From a host perspective, this one host could handle these fine. It could handle this all day long. And we'll talk about overcommitting CPU a bit later on, but that would be fine. And remember, this is on a single host. Okay, so just adding those extra web front ends in front or behind the load balancer is now allowing that scale to grow and that efficiency to be there, and we're not hitting that bottleneck. And you can see how many concurrent, lightweight users we could support on that. With the one web server, it was still in excess of 200,000. And you think, wow, you know, that's more than what Microsoft does. I mean, we'd be fine on that. There's no resiliency in it, but still, we'd be fine from a performance perspective, although the CPU was that little bit high. So maybe we want to put 2 in anyway. But as we scaled it to 2, to 3, we went from just over 300,000 to well over 400,000 users. Now, this is a lightweight test in terms of the user type. You may go with a medium or a high density or a high performance test and find that the numbers are dramatically lower, but that's specific to your environment. Okay, that's specific to your users. And the physical planning information we have on TechNet will help you determine what your kind of what users are. But look at the little line that goes down, the response time. Microsoft recommends a response time or says acceptable response time is between 1 and 2 seconds. Now, as a user, that seems like a really long time. 2 seconds, oh, you know, on an internal site, wow. But you see that the response time, as we added more of those web servers, dropped. It's below half a second. 0.3, say, for when we've got 3 web servers. So great response time. The users are going to have a good experience with that. And remember, these web servers, these web front ends, are 2 virtual procs and 4 gig of RAM. So they're not mind-blowingly massive. Okay? They're realistic. So in terms of the summary of the report they performed, it was over 460,000 simulated users, but that was 1% concurrent, derived from those lightweight users. But you can tailor that how you see fit. You think, well, we're only 2,000 users in our environment. Brilliant. You know, the workload test that you're going to use, you're going to be able to scale and change that kind of load balancer or that load generation tool to really map to your environment, and you'll still see great scalability. But the front end is the bottleneck, but adding those extra web servers alleviated that. And you'll see adding the web servers took us from 250,000 to 460. And the page times, the response times were faster than the recommended guideline. So again, that's a good thing. Okay? But this means nothing in terms of your specific environment. This is validation that actually we can scale really, really big for SharePoint on Hyper-V. Don't be put off. But for your environment, repeat the test. The information is all on the links that I've kind of put them at the bottom there, where you can get the PDF and what they did and so on, so you can replicate in your environment to better tune for your specifics. But your mileage will vary. As I said, this is the test they ran. The environment, your environment would determine and look, I'm sure, very different. But they are good candidates for virtualization. Now, it says here, for larger deployments, consider deploying resource-bound SQL servers and index roles on physical servers. And I think, yeah, in some cases that may be applicable, but as we'll go in the SQL session this afternoon, SQL is a good workload for virtualization now. It's very, very close to physical performance. And they saw with a 4 vCPU, 32 gig of RAM SQL backend, it wasn't reaching those bottleneck. It wasn't the bottleneck for this infrastructure. So it can be done. It can be achieved purely in a virtual environment. But let's look at some SharePoint best practices. Now, from a farm perspective, we've talked about Hyper-V hosts. Great stuff, easy peasy. And clusters. This is where my animation goes into overdrive. I spent a lot of time on these animations and fades and so on. We've got our cluster. We've got some shared storage. We just got 2 nodes. That could be Hypernode 1 and 2 that we saw earlier, or it could be, there could be 16 nodes in here. We've got the SQL backend, which is holding the config, the content DBs, the farm content databases, the search admin database. You get the idea. It's holding the backend of stuff. The application servers, where central admin is, search component, you could have the crawl and you could have the query component there as well, and the web front end, simulated by that little globe. And that you could just have it as a pure web front end, you could put the query component, or you could mix and match some of the other bits and bobs, maybe have CA on there as well. Either way, that's their key farm elements. But when it comes to specifics for Hyper-V and SharePoint, there are only a few. Everything we talked about in Hyper-V at the start is applicable, best practices. But these are specific for SharePoint on Hyper-V. It is a recommended ratio of 1 virtual processor to 1 logical processor. Now what that means is, if you've got 8 cores in the physical server, you could have 8 virtual processors in VMs running on that server. This isn't a technical limit, it's just a recommended ratio to guarantee performance to those workloads. That doesn't matter whether you're running it on Hyper-V, VMware, whatever. You would get away with 2 to 1, but it does say in all of the SharePoint on Hyper-V documentation, wherever you read it, it does say if you start to overcommit CPU, so for example, if you had 8 cores, but you were running 16 SharePoint vCPUs, you may, and there's a may in italics, you may experience performance degradation. Could be 1%, it might be negligible, so you test in your environment. But these kind of examples that I'm going to give really focus on trying to keep as little overcommitted as possible. But what you would also turn off is the auto stop and start. So you would not configure a VM to save state when you shut it down, okay, when you shut down a host or move it, for example. Because if you have one of your SharePoint VMs going into a save state, it's almost like pressing pause. And when you bring it back up, it might be out of sync with the rest of the farm, and that might cause problems. So it's often cleaner to shut it down, let it finish all its jobs and stuff that it's been doing, and then bring it back up at the right time. If you're doing live migration, like we showed before, you'll be fine. But if you're putting it down for a period of time, you just want to take a website or a web front end down, I would use the shutdown rather than the save state. And the same applies for snapshots as well in Hyper-V. Okay? You wouldn't use those because they're equivalent to saving state. And if you roll back to a previous point in time, it may be out of sync with the rest of the farm. So what are the candidates? Well, to be honest, I would say they're all candidates. I don't think there's any part of SharePoint now that cannot be virtualized successfully, providing you've sized in the physical world first. You've sized it for your capacity, for your users, for the services you're going to run as part of SharePoint. However, there are candidates that we would classify as ideal, and there are candidates that I would classify as good. The ideal top 3, the web, the query role, the app role, you saw the utilization of some of those, particularly the application server, relatively low. When it comes to the SharePoint application, when it comes to the application server or the web server specifically, they're a little bit higher, but you can very easily scale those out. Okay? When it comes to the index role and the crawl and the database, you really need to focus on the sizing of those. Okay, that's very, very important. That benchmark test that we showed before had a 4 vCPU, 32 gig of RAM box. Okay? Would I have put that as a 4 vCPU, 8 gig of RAM box? No, because that probably would have been the bottleneck then. So having that accurate sizing, regardless of virtualization, is important there. But absolutely, SQL and some of the stuff the SQL team has done to integrate with dynamic memory can really help from scaling those databases on Hyper-V. So just some example topologies. You can download it. There's a brilliant white paper or a PDF data sheet that goes through. If you were just starting a SharePoint deployment today and you'd never had SharePoint in your environment at all, it starts you off on how you can run POCs, pilots, and so on, and how you would architecturally lay those out. But I've just borrowed some of those and modified them. So this first one, 1 web server, 1 application server, 1 database, fairly small. This is what I would class as a POC type size. Okay? It would support a fair few users, and it's running on a relatively low-end host, 4 core processor, 16 gig of RAM. So definitely a POC. It's something you could do on a high-end desktop. But the problem with these, anyone got any, what would be a problem with this particular solution? Overcommitting CPU, correct. Good point. Any others? No HA, exactly, yes. No HA at any level. So if I lost the host, SharePoint's a goner. If I lose the DB, something's going to go wrong. If I lose the web front end, nobody's going to be able to access it. Multiple problems, but it's there just to prove whether SharePoint is applicable for your environment. It's used to refine the vision for the scaled deployment, because you can get an idea of, all right, well, even in this lower performance environment, how are users finding it? You would only open it up to a smaller subset of your users. But you're getting into best practice around the tiering, separating the data tier from the web tier, from the app tier. That's really, really useful. And it is not designed to generate performance benchmarks, but certainly get a feel of how you would configure it and deploy it. But there is, and you could use dynamic VHDs for this. If you're just testing in a POC, that would be fine. And the size of those, that would be appropriate. However, there's no resiliency, and you've overcommitted the CPU. So yeah, great, exactly. So if you're wondering how have you overcommitted the CPU, well, we've only got 4 cores in the host, and we're using 6 cores for the SharePoint VM. Would it be a massive performance hit? I don't think so. Okay, but the SharePoint guidance always says don't overcommit. Ideally, use 1-to-1. Okay. Let me look at some of the others. The pilot. So we've gone that a little bit bigger. We've got a little bit more resiliency at the web front end. So think back to the benchmark test where they introduced another web server and they could support a whole new load of users. So you may open this up to a few more. We've bumped up the RAM in the database server slightly, and we've increased the size of the host slightly as well. So we've got 8 cores now, maybe a dual processor quad core, and 24 gig of RAM. Now, in this example, are we overcommitted on CPU? The answer is yes. Bad, or not ideal. When it comes to RAM, we've got enough space on there. 8 gig plus 4 plus 4 plus 4 is 20 gig. We've got 4 gig headroom. That'll be fine. However, what happens if we want to scale that a little bit further? We've not left ourselves very much headroom at all. Not very proactive and forward planning. But let's look at some of this. Adding a second web server will enhance that capacity. So you could open up the pilot to more people. Let them in. They're now utilizing the site. They're doing some light workloads, uploading stuff, getting used to SharePoint. We've increased the size of the database. And this is the time that you might start to think, you know what? Now that more users are using it, let's move these dynamic VHDs to fixed. And let's see the performance data change from an IOPS perspective. Let's just see how much performance we can glean from this. And when it comes to doing that or making that process from dynamic to fixed, you can do that through Hyper-V Manager. Click the virtual disk, convert, and it will convert it into a fixed disk of your choosing of size. So it's not a painful process, but you'd be adding a second web server as part of that. We've got the web front end of the query roles on the web server, and we've still got the central admin and the crawl service, effectively, and the indexing that goes along with that on the application server in the middle there. We haven't got all the services that SharePoint provides. We're not doing everything, but at this stage, we're just introducing it and still kind of piloting. As I said, you may want to up it to 32 gig to give you that bit of headroom if you want to increase a single element or a single tier in size. We are slightly overcommitted, but only just. But then we start to introduce resiliency, and I've got 2 examples of this. Okay, 2 examples of resiliency. This is resilient from a SharePoint layer. The database, mirrored. Okay, that's resilient. The app tier, resilient. The web tier, resilient. So we could survive an outage of an entire host, and stuff would still carry on going, which would be good. However, we'd be down to 1 host then, and then we'd be in trouble in terms of we'd have no subsequent resiliency going forward. But what we've done here, we've introduced second versions or second instances of all of those different bits. We have got resilience against those different workloads or tiers. There is resilience against a host failure, and the CPUs are not overcommitted. Okay, there's 8 and 8. That's good. We would expect a good level of performance there. We're still using the fixed VHDs. Remember all the networking stuff we talked about at the start? That's all helping us to ensure performance is optimal. But this would be my preference, okay, from at least a hardware resiliency perspective. Because you're utilizing Hyper-V, you're utilizing clustering, you can take advantage of live migration. So we've got a resiliency here against both hardware and the web front end. With no database resiliency, with no app resiliency, albeit we could restart them on another node or move them around if they become overcommitted. But at this stage, we're not overcommitted on CPU either, so that's a good thing. We've got plenty of RAM to spare on each one. So we've got 12 being used on node 1, 8 being used on node 2, out of the 24 on each. So we've got a plenty amount of room there. If a host does fail, VMs will reboot on another host. So that's why I haven't reduced the host sizes. Okay, because we will allow all the VMs now to run on one host. So we've introduced quite a good level of resiliency there. Introducing that SAN and offloading our VHDs from direct attached storage onto the SAN may give us a performance benefit as well. You would hope so. I'm sure the SAN vendors out there would like to think so. And we can now gain more flexibility. So we can move these SharePoint VMs around. You know, if we think, you know what, The web front end, I'd like to move them both onto Node 1. I don't know why you'd do that, but if you did, then I can do that. I've got the flexibility. Also, patching of the host. We can move them across, patch the host, reboot, and then move the VMs back using live migration. So we've opened up a new angle in terms of our agility. And our CPUs are not overcommitted. Individually, they're 8 logical to 6 vCPUs and 8 to 4, but on failover, they would be slightly overcommitted. But if you've lost a host, a slight performance degradation, if any, would be acceptable while you're working on trying to get that host back up and then balance the workloads as well. That's assuming that there would be any performance hit. I don't think there would be a huge amount at all. Then we start to increase the size, and this is what I would deem for a medium size, and this would support a fair number of users. I mean a fair number of users. This is what I would classify as a medium farm, where we've got multiple levels of resiliency. So we've got the hardware resiliency with Hyper-V. We've got the live migration, all that kind of stuff. We've got the DBs mirrored. We've got 2 application servers, and we've got 3 web servers. This is actually more in terms of resiliency and scale than what the benchmark test had. And that could surface 400,000 users lightweight. So, you know, we're providing a solution here that's very, very scalable indeed. Our web servers are up to 8 gig of RAM each. Would you need to do that? Possibly not. If you can get 400,000 users on 4 gig web servers, use 4 gig web servers. But it does say in the SharePoint hardware virtualization requirements that for production on a medium farm, your web and your application servers should be a minimum of 8 gig, okay, ideally. Your database servers are at 16 and they're mirrored, and our hosts have gone up to 16 logical processors, so 16 cores and 64 gig of RAM. Now those processors could be dual 8 cores, they could be quad cores, achievable today. I'm not saying, you know, you have to go wild out there and try and accumulate some really, really high-end hardware. It's not the case. So here we're utilizing larger scalability. Neither node is overcommitted, which is good. And you'll see host 1, we've got 40 gig of RAM used, and host 2, 32 gig of RAM used. So if on failover, we couldn't support, on a pure memory perspective, all those VMs on one node, or could we? And the answer is yes, we could, if we were utilizing dynamic memory. Because dynamic memory will allow us to specify minimums and maximums for some of these workloads, particularly the web and the app tier. And upon failover, if we're slightly contented for memory, we can take from some of the web servers and give to others. Okay, so we would be able to fail them over. Best practice would probably be an N+1 cluster, so you'd have an extra node. But if you do want to do it on 2 and you want to consolidate down, then your dynamic memory would be very, very useful in there. In fact, at all 3 tiers, okay, because SQL is very efficient with dynamic memory. Hello, there we go. I'm doing the same again. I'm clicking here, and I could just press the key. So these are just a few of the options, but hopefully what you've gleaned is some useful information about how you carve Hyper-V and how you specify the NICs and so on. Do not compromise how you would specify and plan this for a physical workload, a physical infrastructure. The load balancing stuff, the way you would architect from a sizing perspective, they're all applicable to physical and virtual, and there are lots of tools out there. There's a link to TechNet as well. Remember to allow for 1-to-1 ideally, but it doesn't have to be. Test in your environment. See what 2-to-1 or 4-to-1 would do. If it doesn't degrade performance, you're still going to be supported. Plan for failover if you are using high availability and hosts. So how do we enhance SharePoint on Hyper-V? And this is really where System Center comes in. So I'm going to very quickly duck over to my demo machine, which is locked for security purposes. And you'll see some of the value we can add with System Center. So Virtual Machine Manager, how can this benefit SharePoint? Well, VMM has the ability to deploy very quickly from templates. So I could have a template that's got Windows Server, the web server bits enabled, and I could very quickly deploy. For example, if I need to scale out my web tier, right, I need a new virtual web server. Off we go. Deploy very, very quickly from a pre-built OS that's pre-configured with your correct sizing, and the OS is configured with all the relevant admin passwords, product keys. It'll join to the domain. And if you have the ability to automate any form of SharePoint deployment, maybe you do in your environment, or any form of web-based installation of the IIS role, then you can attach run once commands, run once scripts, and unattend.xml files as well. So you can very quickly scale up that infrastructure should there be an increase in demand. We're talking minutes to deploy a new virtual workload. A quick question, yeah? Yeah. So if you were creating a template, a new VM from a template, so the question was around naming, I think. The question was around naming of the virtual machines on the template. Would it clash with anything when you're deploying and scaling out your farm? I think that was the question. So what I'm going to say here is, when you're deploying from a template, you specify the identity information of that particular virtual machine that you're deploying, and you'd factor that in when you're adding it to your web farm or your web tier. But all I'm trying to get the impression of there and give the indication is you can scale up and quickly deploy VMs, save yourself some time as you would in the physical world, and then add it to your relevant farm at whatever tier you're adding it to. But that configuration will be done within the operating system. But once we've deployed and we're efficient, this is where System Center Ops Manager allows us to start to monitor. It allows us to alert on our key workloads, our SQLs, our SharePoints, our Exchanges, really down to the nuts and bolts of what's going on, and see the efficiency there. And we can see that some of our resources are down here, some of our sites are degraded, and we can start to map these different views in a very intuitive way. So we can use things like Operations Manager's distributed applications to visualize things like our SharePoint farm or our Exchange infrastructure or our hardware. And we can build these distributed applications very, very easily and visually. And we can actually present them through Visio services in SharePoint. So we can get a live health-related view in SharePoint of SharePoint, which might seem a little bit weird. But we can drill right down into what's going on in our estate. If you keep an eye on the right-hand side of the column here, all the different commands that appear based on where I am. So if I'm selecting a particular service, I get some stuff I can do around reporting. I can drill right down, but if I go to a particular node, I get commands related to, in this case, the Dell hardware. So the management packs that are out there in the ecosystem really enable me to understand what's out there from my infrastructure perspective. So that's how I would monitor SharePoint at a very high level. But then I can present that back to the business through rich dashboards. The service level dashboard is a free bolt-on to Ops Manager that allows me to visualize SLAs against different elements of my infrastructure, services that I'm providing to the business, my SharePoint infrastructure, my HR web. Everything's green, everything's good. Good times. You know, we're in a good place with that element of our infrastructure. We can put service levels against that, 99%, and also see how we're performing over time from an availability perspective and a performance perspective. But finally, we've also got DPM, which can be used to protect efficiently SharePoint and restore it in the event of a disaster. And DPM includes a nice feature called DPM to DPM for DR. So if I'm using Data Protection Manager to protect on one site, and I'm protecting all of my stuff, my SharePoint, my Exchange, my SQL, and I've got a second site that I use for DR, I can have another DPM server here protecting that DPM server and its workloads and stuff. So in the event of a disaster and I lose everything on that site, I can restore to my second site utilizing that secondary DPM server. And the DPM server, the bit that's doing the backup jobs, is free. You only buy the agents for the stuff you want to protect, so you can put as many as you want. Some people have disk protection over here, tape protection over there. So a lot of enhancements around System Center integration. And finally, NetScaler for that load balancer. You could use F5, you could use NetScaler. This is a load balancer that can be deployed through Virtual Machine Manager as a virtual appliance. It's got pre-configured wizards in it for things like SharePoint and Exchange, so you can very quickly load balance. And it's pro-enabled, which means if Ops Manager is integrated and monitoring stuff like NetScaler, should there be problems in the estate, we can move around virtual machines based on the changes. So lots of chat resources, lots of resources there. Thank you very much for coming along. I know it's early, and bear with me. Have a safe drive home for you. Have a safe flight home for everybody else. And yeah, thank you very much for coming, and enjoy the rest of your day.
Excuse me, I have a question. It may be kind of...
Oh, yeah, sorry, yeah.
Although you didn't address this, something we found, we have a Dell box as well.
Right.
Natively, right out of the box, I think it's almost something that every administrator does, where they'll just team the cards right out of the box.
Yes.
We were in a class yesterday with virtualization tips and tricks, And they said, if you're going to do that, you literally need to add another network card onto the box because the resources for the team cards are not available to the virtual host for the VMs because the resources are already spoken for. And we found that right out of the box, creating a new VM or a template, the template would die in the process where it goes to access the virtual NIC card because the resource isn't available until we put a secondary card in. As soon as we put a secondary card in, we use an Intel rather than a Broadcom.
Yeah.
It worked just like that.
That's in the host?
That was in the host.
That's interesting. I've never heard that before. That's interesting. I think.
And it had more to do with teaming the card right out of the box when we created the 2008 R2 box.
Yeah.
And secondarily, it's a Broadcom issue.
I could not comment on the Broadcom issue, but yeah, I know what you mean. No, I know, yeah. So having
because
those...
the resource wasn't available, and it didn't matter what teaming software we used. We were using the one from Dell, like you suggested, as well, but...
So were you sharing the parent management NIC? So were you, when you were creating the virtual switch, you were saying allow management OS to share this NIC?
Yes, absolutely. Yeah.
Right, okay.
And what happened was the teaming software essentially got in the way. If we unteamed the cards, it worked just fine.
Yeah, yeah.
But as soon as we just put a dual port Intel card in the box, pointed to the Intel card. It didn't matter if it was legacy or not. Bang, it worked.
Right. Okay, that's interesting. Did they give you any feedback in the tips and tricks session?
They did. Said don't team the network cards or use a secondary card.
Wow. Okay. Well, yeah. I mean, the teaming side, I think it's the way you do gain the resiliency. I think you could use secondary cards for each of the NICs, but your network adaptive view in Windows would be ginormous and a little bit more difficult to administer. But yeah, I think certainly I've had success with Broadcom. HP we've done a lot with, especially with Flex 10 and stuff, and the Intel stuff is pretty switched on. It's got specific settings now for virtual machine load balancing and stuff. So yeah, I think it's a lot further on than it was. But I'm surprised they're still having what seems like a basic issue there. But yeah, thanks for bringing that up. All right.
Got an HA question for you?
Yes.
Okay, so you showed, interestingly, two different slides. One, trying to provide HA via the Hyper-V hosts.
Yes.
The other one, leveraging the fact that SharePoint has some HA strategies built into it.
Yes, correct.
One of the questions I have for you is maybe out in the field or as you deal with customers, particularly when you want to have a situation where you have data center resiliency.
Right.
Obviously, in that Hyper-V diagram, you had shared storage.
Yes.
Are you finding folks that are kind of maybe leaning towards leveraging the SharePoint HA option? I know that we struggle with that, especially with the cost of synchronously mirroring SANs between multiple data centers. Yeah,
I think that's an interesting point. There's no right answer. We see people doing both, and I think if people have got two data centers, what they're looking to do is actually typically virtualize across both, have a DR and have that replication, which is expensive. It's an additional cost. And they're failing over typically at the VM level because that will give them enough of their SLA. I mean, it depends on your RTO. If you can survive and go to DR site within 4 hours and your whole SharePoint is back up and on running as it was before, separated across cluster nodes now in the second site, then that's a great solution for them. But if you need that pretty much instant tick over for SharePoint, where you've got website servers in the two sites, you've got application servers in the two sites, and the database, that would give you a faster level of recovery, I'm sure, because even these site recovery tools from the likes of VMware and so on, there's still going to be an element of time and bringing stuff back up in the right order and stuff. So it's a really, there's no right answer for that one, I'm afraid. It's really tricky, but from a cost perspective, I'm guessing if you were splitting SharePoint across the two sites and having them running concurrently, it's going to be more licensing cost versus if you're going to run them on one site and have the whole block fail over database. And you can time them to come back up in the right order as well. So when SQL starts first, let it get settled, then start up the app server, then start up the web server tier, and then users will start to be able to access it. But certainly these were just a snippet of some of the different options, but it's very, very difficult to say.
You see customers employing both strategies?
Yeah, absolutely. It's a lot of them are doing virtualization first, and then the workloads just go from site to site. But it does depend. It depends how many geographical locations they've got. If they've just got main site and DR, then that's one option. If they've got main sites in Redmond, main sites in here, and users are active in those sites, then it makes sense to have SharePoint in every site. All right, no worries.